What I've been doing is thinking about recent and future trends in exploration, and actually sort of set up today and in a way the next forum we have, which is due on February the 15th, to answer the question, what is the technology breakthrough that we actually all need and are all looking for? And to structure my thoughts a bit, I've been using the internet to gather statistics on what happens in exploration. And it probably seems like a rough and ready technique, but actually when you sit down and look at, I have lots of people who send me news service sheets and cuttings, analysis, all that sort of stuff. When you start actually compiling those and looking what's going on, it's pretty clear where the main hot themes are in exploration today. And you can also cross-check those with what companies put on their websites, because the rules on disclosure are, roughly speaking, this is a Tullow interpretation. If you tell one person, you've got to tell everybody. That means there's a tremendous amount of stuff about what people are doing, what wells people have drilled, what plans they have, what hot areas they see on the internet. So I have, out of that, distilled sort of four themes, and they're pretty obvious exploration themes that have occupied the digital space for the last year or two and look like occupying it for the next little while. And they are, and as I say, they're tremendously obvious. They are deep water, the Arctic, unconventionals, and sort of mid-continent things. And actually, if I looked on my desktop and said, what's the dominant source of cuttings, clippings, news items, notes, etc., it is unconventional stuff by an order of magnitude almost. I would say 75% of what I have is unconventional gas. But if you look at each of those in turn, and this is going somewhere in technology, but in a way we need to start talking about these exploration themes and the geographies that go with them. If you talk about deep water, of course, the most significant event of the last year was the Macondo, or Deepwater Horizon tragedy, and its impact on the Gulf of Mexico. And there's a lot of questions at the moment about when will Gulf of Mexico exploration get back to the sort of speed and ease of working that it had, let's say, 18 months ago. And I noticed about a fortnight ago, the guy whose job it is to now structure and then regulate the industry in the States said, well, actually, the answer to that question is never. It never will get back to the ease of licensing, the ease of permitting, the relatively shortened timescales. I actually said probably never, but when a government official says probably never, you can kind of figure out what he means. Meanwhile, if you look around the world, deep water activity is a tremendous hot theme. Having declared my interest in Tullow, because I'm on the board there, of course, we've been very active in Ghana, along the whole West Africa Transform margin. This year we'll drill 2 or 3 key wells in South America, deep water, testing more or less the same play that we've looked at in West Africa. You go south of there and of course you have the subsalt. Elsewhere in the world, offshore China seems to be getting a certain momentum in deep water, offshore Australia, activity west of the Shetlands and so on. So quite vibrant deep water activity at the moment. If you move on and think about the Arctic, first thing to say, of course, is the Arctic has been active for 50 or 60 years. It's not newly invented by youngsters today. I mean, Alaska was being explored in the 60s, West Siberia by the Soviets in the 70s and 80s, all within the Arctic Circle onshore. I mean, the change now is the belief that for various reasons, the melting of the Arctic Ocean amongst them, we'll see much more offshore exploration. And of course, Cairn, for example, have made a start with that this year. And Russia and Norway have recently penned an agreement that opens up the Barents Sea for sort of mutually advantageous exploration between those two countries. So you're going to see seismic activity there. And 2011, I think, more of that. The Barents multi-client seismic, Greenland, I believe Cairn is planning to add $500 million to the $400 million they spent last year in drilling. I think you drill, what, 2.5 wells, let's say? 2.75?
3 on a sidetrack.
Okay, 3 on the sidetrack and more next year.
Yeah.
Oh, this year. Sorry, yeah. And you can see, you know, one of the mentioned outcomes of the recent alliance between BP and Rosneft. 125,000 square kilometres of the South Kara Sea. Now that is what, 25 offshore Angola deepwater blocks. It's quite a large area. But as I gather from them, nothing's going to happen this year. I mean, you'll start seeing seismic being shot in 2012, I think. Unconventional space, I mean, dominated by shale gas in the US, huge amounts of activity. One thing you can see, though, is that certain companies are beginning to leave the gas arena, the shale gas arena, and move into shale oil. And that means they're moving and migrating out of, not necessarily out of the southern states, that's an exaggeration, but it opens up opportunities in the northeast, in Michigan, and states that were oily 50 years ago, or 60 years ago. Favourite little niche of mine, not personally, but just to watch, is that the area where I grew up, which was northwest England, sort of North Cheshire and Lancashire and so on, is going to see lots of activity. Well, plenty of activity, chasing coal bed methane and shale gas. And there's a company drilled a well about 5 miles east of Blackpool Tower, I seem to recall from last year. And then finally, talking about onshore, and you'll see the point of this sort of monologue in a minute. You know, exploration in Russia itself has actually been withering on the vine because their tax regime is punitive, or at least regarded by Western oil companies as punitive, largely because the Russian state depends on the oil sector to support it in the manner to which it's become accustomed. I mean, maybe the fact that Russia and China have just signed a pipeline agreement for East Siberian oil will open that area up, maybe. In Africa, as you know, again, I have to declare my interest. I mean, the East African Rift System, Tullow has been active there, and everybody else is getting active there. And everybody is also thinking now, where else is there in the mid-continent of Africa that we could go and explore efficiently and effectively, bearing in mind that certain governments need to change their attitude before we're going to do it at all, or change their expectations. Now, the reason for going through that is if you were to pick out and label each of the things I said, I was talking about the onshore as much as I was talking about offshore. You know, onshore in North America, chasing shale gas and shale oil, onshore in Africa, chasing mid-continent and in the Rift System, onshore in Russia, actually exploring again in the West Siberia Arctic, exploring in East Siberia, and so on. And Even the last time I looked, North Cheshire and Lancashire were still onshore. And then I'm going to say quite broadly, I think that the technology know-how for onshore exploration is miles behind what we can do offshore. And the reason for that lies in the sort of presentation you heard this morning, or let's say the sort of presentation you heard this morning from PGS is an enabler of the fantastic things we can do offshore. So, dig into that in a bit more detail. You know, I personally, and many of you, have lived through the start and realization of the fact that huge exploration, also could call them regional 3Ds, are the main driver of exploration success in deep water. So you can look at offshore blocks in Angola, 5,000 square kilometres, and say effectively that is covered with proprietary or increasingly multi-client 3D. And you can conceive of loading up the whole of that 3D to a workstation and interpreting it pretty quickly. And the important thing, and somebody, I think it was Chris, was saying, Chris Page was saying, well, of course the effort involved here is 4 times a conventional survey, or maybe 6 times a conventional survey. Multi-client 3D data at the base is available at about $3,000 a square kilometre. And that's an important number that I'll kind of reference in a minute. So what you have is driven by, and I think probably need to give due credit to PGS 15 years ago, introducing the ramformer technology where they could tow many streamers, many more streamers than anybody else could tow at the time, and they drove down the cost of acquisition. So now we benefit from a situation where you have incredibly efficient marine acquisition, very rapid processing, and workstations that were invented by a couple of entrepreneurial companies called Landmark and GeoQuest that actually enabled us to deal with the vast amounts of interpretation data that resulted from this transformed technology. So, and you know, as I was going to claim that I'm the oldest person in the room, and that would be unfair because first of all I know Ian Jack is here, and secondly there are a couple of other people I know, but as they were once my really senior bosses, I won't mention the fact that they're older than me. But you know, going back to the mid-80s, you know, just remember as an old codger, it's remarkable that in the mid-80s it would take us 2 years to go from designing a 3D to having the actual final traces anywhere near our offices, and then we wouldn't actually be able to interpret all of it because we had to interpret it all on paper, and we'd interpret one section in 10 or one in 5 or something like that. So the transformation enabled by fantastic acquisition, satellite and other based processing, and these marvelous workstations we have is just phenomenal, where you start measuring things in a month, in a few months, let's say, rather than 2 years or more. So offshore, 3D lies at the heart of everything we do. You can wind sophisticated chronostratigraphy in there, you can perceive sophisticated sedimentological models in there, you can do facies analysis, you can do rock physics, and in some cases you can do direct hydrocarbon detection. Now, as soon as you talk about onshore, that story is, in the main, completely different. Now, I heard a presentation the other day when an ex-colleague of mine was talking about exploring in Colombia, onshore in Colombia in the Llanos foreland. And what he said was now everybody there explores with 3D seismic. They're actually chasing pretty small accumulations, sort of 1 to 10 million barrels. Companies such as Pacific Rubialis and so on. And they have exploration success rates of as high as 75 or 80%, which is exactly what people with marine 3D in Angola and the Nile Delta and Brazil and Ghana and so on are delivering today. But that 3D is costing them $30,000 a square kilometre. So $25,000 to $30,000 a square kilometre. So an order of magnitude more than marine multi-client 3D. If you step back into the Yarnus foothills, you know, where it's mountainy and people have to walk up the side of hills to do things, you're talking about $110,000 a square kilometre. I'd hope to be able to say, oh, it's 2 orders of magnitude worse, but or better, depending on who you are. But, you know, $3,000 a square kilometre for surveys that will cover 5,000 square kilometres offshore Angola or Brazil or Nile Delta or Trinidad or you name it, west of Shetland, offshore China. To 10 times that, to 15 times that, to 20 times that, to 30 times that, 40 times that for exploring somewhere else where you finish up doing postage stamp exploration, postage stamp regional. Well, postage stamp and regional geology are not words that you can use together. And therefore, in modern terms, the exploration job is not being done properly. I assert. I may be completely wrong, of course. So, clearly my contention is that onshore seismic has simply not seen, and particularly the acquisition technology has not seen, the transformation that was introduced offshore 15 years ago. And as my learned, you can always tell when I want something because instead of referring to Ian as old, I now refer to him as learned. My learned ex-colleague Ian Jack and others like Bob Heath from iScience have said the absolute key here is the slow pace and manpower intensiveness of using cables onshore. You know, and when you look at photographs of what I could only call a cable farm waiting to be deployed in an onshore 3D, it's just mind-boggling. And all the people, of course. So we have looked for a while, I would say for, 10 years, for a breakthrough in the advent of lightweight, wireless, digital, long life, long battery life seismic systems, and it's a bit like democracy in certain countries. You know, there have been many false dawns, but perhaps this year we're going to get there and see the signs, and that is the reason, really, for the 2 talks which follow me. One from Wim from Shell. He's going to tell us what Shell is doing, and then from Gary Jones, who many of you will know from a previous life in a major seismic contractor, who is now the chairman of wireless seismic. So with that, I mean, that's all my